So representing valence electrons with dots. Obviously, this is a gross oversimplification, but most students are pretty okay with that. The whole particle wave thing, that was a bit much. Here, we're just going to draw dots. This is really nice because we just draw dots and move them around. So the valence electrons are the ones that are important. They're in the outermost principal energy level. They're the most loosely held. So if you're going to lose any, it's going to be the valence electrons that get lost first. So in a Lewis symbol, we show the valence electrons as dots around the element symbol. So we're going to draw the Lewis symbol for oxygen. And get things set up here. Colors. So we need the chemical symbol for oxygen. So that's wrong marker. O, right? And then we're going to draw dots around it, and we need to know how many valence electrons does oxygen have? 6. How did you know that? It's in group 6, right? Not so hard. So I'm going to put 6 dots around the oxygen. 1, 2, 3, 4, 5, 6. Now, exactly where you put those is not that important. There's lots of different ways you could arrange them. But we do typically use the top, the bottom, the left side, and the right side. And you put 1 or 2 on each side. And it's a little bit like dice, right? Dice always have the little pips arranged in the same patterns, because then you can just look at it and see 5. You can look at it and see 6. You don't need to count them. Remember playing Monopoly with kindergartners? Bad idea. Roll the dice, and they were counting all the spots. So tedious. Because, they couldn't add, and then they couldn't just see it either. So by doing top, bottom, left, and right, then we don't have to get our finger out and count dots all the time. Okay, just a convention. Did you have a question? No? So dots are placed with a maximum of 2 per side, just a simple way to visualize. Atoms with 8 valence electrons are said to have an octet. Just like in choral music, you've got 8 people singing together, it's an octet, right? This is particularly stable. Helium, of course, little guy, is an exception. It has a duet of 2 electrons. It's too small to have an octet. And so we have what's known as the octet rule. And this is an important guiding principle. That atoms will transfer or share electrons to achieve an octet of valence electrons. Nonmetals with each other will share them so that everybody has 8. Metals and nonmetals together will transfer them. The metals will lose them, the nonmetals will gain them. And we already saw how those predictable ions all end up with electron configurations like the noble gases, and that would be 8 valence electrons.